Today we're going to talk about another kind of function that does not return a value, and it simply performs some kind of action such as reading some values or writing some values. And we're also going to talk about a second kind of parameter passing mechanism called call by reference. We're also going to see that void functions and call by reference are often used together because one limitation of functions that return values is they can only return a single value, and oftentimes we want to be able to return multiple values from a function, and call by reference is a parameter passing mechanism that will allow us to do that. So today the agenda is void functions and call by reference. And as I just mentioned, void functions do not return any value. They're like a function in every other respect. You'll often hear us refer to void functions as procedures, and that's just something from back when computer science was in its infancy, and functions that did not return values were typically called procedures. Again, to indicate that it does not return a value, use the void keyword. It says this function does not return a value, and now the return statement, should you use one, must not return a value. It should simply be immediately end it with a semicolon. And because the function doesn't return a value, it's okay to omit the return statement, because when the function body finishes executing, the function naturally returns. However, it's here's a common example of a void function, which is it's being used to print some information to the display. In this case, I'm printing my name to the display, and I'm passing in the name, and then I just have a series of cout statements that print out, hello, my name is, say, Brad, what can I do for you? And again, this return statement is not necessary. I could actually delete it and my function would still work. Now you can use a return statement just as you could in the functions that return values if you want to return from your function early. So here we're printing the square root of a number, but we can't print the square root of a negative number. That's meaningless. So if the user gives us a negative number, we're going to print out a message saying a positive number is required, and we'll return without printing anything. However, if that succeeded, if they gave us a positive number, then we're simply going to print the square root and of x is equal to, and whatever the square root of x is. Remember, square root is a predefined function. It returns a double, and we would include it using the CMath library. Now, because void functions do not return values, they cannot be used in expressions. Remember, an expression is something that returns a value. So square root was a function that returned a value, and we could use it in either an output statement or an assignment statement. By contrast, void functions do not return any value. For example, the greetings function that we declared and defined a couple slides back, it just prints out a greeting but doesn't return anything. Therefore, if we try to place it into an expression like an output statement, the compiler is going to complain because it's going to say, hey, look, you want to print something, you're saying cout, but greetings doesn't return a value, so there's no value to print. Like the cop used to say, nothing to see here, and in this case, nothing to print here. So when you use a void function, you use it in a statement. Statements don't return values. And the most common way you'll see a function used, a void function used, is the way I've highlighted here. It's just the name of the function and then its parameter list. This is called simply a function invocation, and it will do whatever it needs to do and then return. So let's now try to write a void function. We're going to write a procedure. Remember, procedure, when I use the word procedure, I mean a void function. So I want to print a date that takes a month, a day, and a year, and it's going to output a formatted version of the date as month, day, year. So for example, if I call print date this way, it would produce the output February 23rd, 1964. So let's get to work on that. We want to have a void function because that's what a procedure is, named print date. And it takes three parameters, a month, day, and year. So it looks like the month is a string, looks like the date is an int, and it looks like the year is an int, just from the example data. And now I just want to print it. So I'll print the month first. And then I need a space between the month and the day. Then I'll print the date. And now I need a comma and a space. And finally the year and a new line, which I'll put on a separate line. And that's it. I don't need a return statement. That will print out the month, the date, and the year on a nice line by itself. So that was void functions, and a handy parameter passing technique that we're going to use with void functions is something called call by reference. To motivate it, let's say that I want to write a function that swaps the values of its two parameters. So for example, if I have x equal 10 and y equals 30, and I call swap xy, when the function exits, I'd like x to be equal to 30 and y to be equal to 10. Well, I'd like to do that using a void function, but right now there's no way to have changes to the arguments, changes to the parameters be reflected in changes to the arguments. Remember, call by value copies the values of x and y into the parameters. So x and y will be copied into the parameters for swap, but then when I modify the parameters, that will not change the arguments x and y. So the solution that the C++ developers came up with was this concept of an output parameter. An output parameter can change its argument. So the name that they gave to an output parameter was call by reference. Yes, it would be much nicer if they just called it an output parameter, but they didn't. You declare a parameter to be an output parameter using an ampersand. So you place the ampersand immediately after the data type and before the parameter name. So that makes it what we call a call by reference parameter. So you'll hear me refer to them both as call by reference parameters and as output parameters. And you see it needs to be declared as a output parameter both in the function prototype and in the function definition. Now let's see what happens with this actual call to swap. So we're going to, let's say that up here we declared min and mint, and there really should be a cin statement, so I'll add one, cin min and max. Okay, and let's say let's just make, there we go, make it bigger. So let's say we enter 30 for min and 10 for max. So you can see that what we're wanting to do is if min is greater than max, which it is here, we want to swap the values so that min ends up with the minimum value and max ends up with the maximum value. So we call swap, and we've declared x and y as output parameters. So they'll get the values for min. Min gets copied into x, and max gets copied into y. And initially temp is a question mark, but of course we immediately assign the value x to it. So the value of temp becomes 30. Now we assign the value of y to x. So x becomes 10. And because x is an output parameter, the change gets echoed back to min as well, because min and x are associated with one another. Now, the next statement sets x to be equal to y. So, I'm sorry, that we just did that statement. Now we set y to be equal to temp. So y gets the value 30, and again, because y is an output parameter, it also modifies its argument, which is max. So max becomes 30, and you can see this is what we wanted. The minimum, min now holds the minimum value and max holds the maximum value. Okay, so this is the beauty of output parameters, is they allow changes to the parameters to be echoed back to the arguments. Also, just a quick note, notice I needed this temporary variable here that I called temp. If I didn't have temp and I made the natural looking assignments like this, let's see what would have happened in that case. X would have been 30 and y would have been 10. There would have been no temp. So the first thing that would have happened is x would have been assigned the value of y. So it would have changed to 10. And just a second, up here we originally had min was 30 and max was 10. So that would have also changed the value of min to be 10. Now when we assigned x to y, y would not change. It would stay 10, max would stay 10, and we would not have successfully swapped the two variables. Okay, so again, just to quickly review, to declare call by reference parameters, we need to place an ampersand after the data type but before the variable name. And that goes both in the function prototype and the function definition. We don't use the ampersand anywhere else. It's only to say to the compiler this is an output parameter. So when we call swap, there's no evidence of that ampersand. And inside the function body, there's no evidence of the ampersand either. So ampersand is kind of a shorthand way. It would have been perhaps so nice if we could have just said, for example, maybe output int x, but we can't. Again, they chose shorthand, so just like we use shorthand in text messaging, they use the ampersand as shorthand for this is an output parameter. So here's just that review. The place where you declare it is, or use the ampersand, the only time you use it is to declare the parameter, and it makes the parameter an output parameter that can change the argument. Okay, so let's say that we wanted to write a void procedure named getInput that takes two integer parameters named miles and gallons. We will prompt the user to enter miles driven and gallons consumed, and we'll read these values into the parameters. So basically what we want is we want getInput to return two values, and we can't do that with a normal function. A normal function can only return a single value. So we're going to combine a void function with call by reference to get what we want. Okay, so we're going to use a void function, and we already know it's named getInput, and it takes, what does it do? It takes two integer parameters named miles and gallons. Okay, miles and gallons. Now we also said that we want this procedure to return these values to the calling function. That is, they need to change the arguments, and therefore we need to declare them as output parameters. And notice I could have declared, I can put the ampersand next to the data type or next to the variable. It doesn't matter, and you'll see me do it both ways. It's a matter of taste. Okay, so I've declared them as output parameters. Now I need my function body. So I need to prompt the user to enter miles driven and gallons consumed. So cout, please enter miles driven and gallons consumed. And now I'll simply read them in. Read it into miles and into gallons. If I want it, I could put a return statement here, but again, it's not necessary in a void. But notice the cin will have an effect because miles and gallons were declared as output parameters. Therefore, when I read my user supplied input into miles and gallons, it will change the arguments that were passed to get input. So as an example, here I've declared two variables in main called miles driven and gallons consumed. And I've called get input with miles driven and gallons consumed. And when I come out of, or when get input returns, miles driven and gallons consumed will have been set to the values that I read into miles and gallons. And therefore, when I print out the miles per gallon here, it will work properly. Now, for those of you who want to know what goes under the hood, so to speak, how does C++ actually make an output parameter? Listen on. This will just take a couple minutes. If not, just listen and try not to get too confused. Just remember that when you use call by reference, what you're really doing is declaring an output parameter and that it can change the argument. How it does it is that C++, let me look at a pictorial image. So what's really happening is that C++, instead of copying the value of the arguments to the output parameters, is actually copying the memory addresses. So min is stored at address 8 and max is stored at address 12. And therefore C++ is copying the memory addresses. And C++ is able to keep track of which parameters are output parameters and hence store memory addresses, and which ones are input only or call by value parameters and store values. So let's kind of look at what really happens when this swap procedure executes. So as before, temp gets the value of x. So temp gets the value not of 8, okay? It doesn't get the value of 8. Instead, C++, seeing that x is an output parameter, follows the pointer, the memory address, and goes up to memory address 8, finds that the value is 30, and assigns that into temp. It now goes to this statement and says x equals y. Well, it does not assign 12 to x. Instead, it says, oh, x and y are output parameters. I need to go and, for y, look at its memory address, which is 12, and it has the value 15. And now I'm going to store 15 into memory location 8 because that's what x points to. So 15 actually gets placed into memory location 8. Now we execute the statement y equals temp. Okay, temp has the value 30, but y is an output parameter. Okay, so 30 gets actually placed in memory address 12. And again, you can see that min and max have their values swapped. Now, if this seems confusing to you, that's fine. I think that when you're starting out, the much easier way to think of it is simply that we're actually assigning values down here to x and y. So it's probably a lot easier to think of originally min was 30 and min was 15. It's probably a lot easier for you to think of x as having the value 30, y as having the value 15, and that when we modify x, it modifies min as well. But it really is the case that x stores the memory address of min and that y stores the memory address of max, and that they directly retrieve their values from min and max and set the values of min and max. So in summary, when should you use call by reference? You should use it when you need to have the parameter change the argument. Or another way of thinking of it is when the parameter needs to be an output parameter, when it needs to return a value to the calling function, use a call by reference parameter. If not, you should use a call by value parameter. So a call by value parameter is input only, whereas a call by reference parameter is an output. So it can do both. You can both read it and you can do output to it in the sense that it will change the value of the argument.